Hi everyone, my name is Sukriti and I'm here on Techie Podcast with a very special guest, Tim Faulkes, who is the Chief Developer Advocate at Aerospike. Tim, welcome to the show and thank you so much for joining us here.
Thank you very much, Sukriti. It's a pleasure and looking forward to talking to you.
Absolutely. So I think we should just kickstart the conversation by understanding, what you do at Aerospike, and if you could just brief us around your role.
Okay, so I've been at Aerospike a long time. I've been here for about 9 years now. I started as I built the solutions architecture team. So talking to customers and looking at their problems and understanding what they're trying to achieve, how they're trying to do it. My background is engineering, so I've been an engineer for more decades, I'm going to admit, in the public forum. But now I've sort of moved into developer advocacy. I want to make sure that developers understand the differences. Coming from a SQL background, what is the difference about NoSQL? How do you make that transition into the NoSQL world? Why would you bother? And avoiding those pitfalls. So it's really great being able to help people solve real world problems and seeing the outcomes.
Okay, so when we talk of the entire SQL to NoSQL migration precisely, Tim, from a developer's perspective, please help us understand why is this entire migration such a hot topic today, and what exactly developers should keep in mind while doing this entire migration?
That's a great question. There's a lot of reasons why. In traditional systems, we've had a monolithic system, be it Oracle, be it a SQL Server, MySQL, whatever. Those systems are great systems and they're not going to go away. The problem is that they tend to have limits. Those limits will cause people to try and work around the limits. They might say, I can't get my throughput properly, so I'm going to put a cache in front of it. They're going to make your ecosystem more complex. It makes developers' lives far more complex because they now have multiple steps to go and read or write any piece of information. It's painful. So the SQL systems are great, but they're not designed for very high throughput. Also, if you scale your data, there's a lot of development organizations out there that have said, I have too much data. I can't just put it in one system. So I'm going to shard or break my data up into multiple different segments and manually manage that. Now that's tricky because getting the sharding right and saying what's going to work for me tomorrow is going to work for me in a year is very difficult. So that growth where it's exponential is very difficult. Mm-hmm. So that's why NoSQL is coming in, and particularly where we are with AI and the advent of AI, there's a lot more needs for data. We're becoming a lot more data centric.
Right.
And SQL systems aren't really designed for those challenges. They're great at some things.
Okay.
But I'm commonly seeing there's a difference between NoSQL, which is designed for very high scale, very high throughput.
Okay.
SQL, which is your traditional relational databases, and then the new SQLs, which are, I want to run SQL, but I want to run it across a distributed platform so that I'm not running on a single point of failure where if that one node goes down, suddenly my application is dead. And there's pros and cons of each of them. And it's a tricky landscape. When people are trying to determine which way to go,
right,
it's really, what are your challenges? Where do you want your business to be taken?
Okay.
If it is, I'm very happy with my monolithic database, but I want to be able to have the resiliency. I want to be able to maybe run in the cloud or maybe run across multiple zones or regions so that the loss of any piece of technology still enables my application to run. You're probably looking at a new SQL.
Okay.
If you're facing scaling challenges so that you've got, I want to do 1 million transactions a second or 10 million transactions a second. You're not going to get that out of a SQL database. With new SQL, because they're now distributed, they tend to actually be a bit slower. If I'm running Postgres on a single node versus a distributed Postgres, in many cases, I have to do network hops, and that actually slows my queries down.
Okay.
So performance on new SQLs tends to be the same or sometimes a little worse than SQL systems. NoSQLs are designed for that high throughput, high performance situation. And they can scale massively. We talk about petabytes. Now, it's really rare to get to petabytes.
Okay.
But a traditional SQL system will start at gigabytes. As it gets into terabytes, it starts getting harder. And as you go up the scale, it gets harder and harder. And so many systems fall off. So even in the NoSQL ecosystem, which one you pick depends on your requirements that you're trying to get to. If you're trying to just get throughput and you know you're never going to grow your data, then an in-memory system is better. If you're trying to get scalability on both transactions and the amount of data, then you'll need to look harder. What are my requirements? Which of the many NoSQLs out there will solve the problem?
All right.
So there's multiple different facets to look at, and see, even not as simple as which technology should you choose. I'm just going to pick it. I need to look at my requirements or my scenario and pick the right technology for it.
Yeah, I think that's a very interesting part of the entire migration when we talk of Tim. Moving on to the next one, I would like to touch base a little on the part where we rethink the entire data modeling. How should developers actually rethink the entire data modeling when transitioning from SQL to NoSQL? What are your, maybe any tips that you would like to share with our audience today?
Yeah, that's something that I'm very passionate about. I'm actually starting to write some material on this because it is a mind shift. And some of the things that you don't expect, like my background was historically in SQL databases. And moving to NoSQL, I discovered that it's not uncommon to have a time to live on records.
Right.
Now, my background was financial services. If you throw away records in financial services, it is the end of the world. If my account balance is gone, then it's meaningless. So having a time to live really was a mind shift. But there are use cases out there where it's necessary. If we look at something like ad tech, they keep data for a period of time because after 30 days, what I've seen on my phone has no relevance on what I might search for in the future. So I need to be very cognizant of that. In financial services, I want to keep that information forever. So fundamental mind shifts like, do I need to keep my data? How long do I need to keep it for? What are the pros and cons of throwing it away versus having it automatically deleted?
Okay.
NoSQLs are designed for speed. They don't necessarily do the joins. They don't necessarily do the transactions across multiple records atomically like you're used to with relational. Now, that depends on the NoSQL which you're using. Okay. Some of them do, some don't. If I'm doing something for speed, I would typically do denormalization.
Okay.
In relational databases, I typically want to do third normal form, fifth normal form, where everything is non-duplicated. That gives me the most reliable data and the best access to the data.
Okay.
In NoSQL, I actually want to put those records together. It gives me speed of access, but it also allows me to do things like cascading deletes.
Okay.
Most NoSQLs don't have a schema. They are schemaless.
Oh.
That's, as I said, most, but certainly not all. Right. If you look at a Mongo, it is schemaless. Something like Cassandra has a schema. Aerospike has no schema. So I have a lot of flexibility, but it means that I can't do things like automatically cascading deletes. In a SQL world, I'm used to setting up a foreign key, and I want to say, if my parent object goes away, automatically throw away this set of children. I don't want that relationship. If I denormalize that data and those children become part of the parent record, then that automatically applies. I can delete that parent record, all the children go away.
Okay.
But if I can't do it, I have too many children. I don't want to fit it all in one record because it starts giving me performance downsides.
Okay.
Then I need to look at how do I do those cascading deletes. So there's many factors around it. Getting that high performance that NoSQLs are renowned for does have a cost. You have to think harder about your data. It's not always, I'm going to prescriptively do this. You get choices. Okay. I want to do this or this or this. And which one I pick comes down to what my use case is and primarily what my business objectives are. Okay. Do I care about the high speed? And if I care about high speed, is it on all transactions? Okay. For example, credit card fraud. Yeah. I've done this at numerous credit card processors. Okay. They want to store all your transactions. When your transaction comes in, they want to look at your historical data and say, based on Tim's most recent transactions, it might be 50,000 transactions. Right. Based on the merchant's 50,000 most recent transactions, what should I think of this transaction? Is it fraudulent? Is it non-fraudulent? Right. So in order to do that, they need to load a lot of data very quickly. If they put that into one big record, they'll just read one record off drive, but it means that adding a new transaction is very, very heavy. They have to take this huge record and chop it and rewrite the entire thing. It becomes a big load on disk. That slows it down. Okay. Whereas if you sort of denormalize it a bit or normalize it more into a relational format, but not exactly the same, then it again gets performance. Okay. So many of these NoSQL databases do give you a lot of the tools that a SQL database do. They give you secondary indexes. But whether they use those or not for a right particular use case comes down to what you're trying to achieve. Okay. So is it more like a segmented working functional activity that we are trying to look at, Tim, when we talk of this migration entirely? depends on what you're trying to achieve.
Okay.
So some data, yes. And NoSQLs are all distributed as far as I'm aware.
Right.
So you're always going to get that resiliency. Now, it also comes down to, there's a theorem called the CAP theorem, which says in a distributed system, and choose availability or consistency. Even something as fundamental as that may not make sense to, what makes sense in one vertical may not make sense in others. In ad tech, I've had an ad tech customer say to me, if we lose 10% of our data, we don't care. It'll regenerate itself as your clickstream comes in.
Right.
Financial services, you want no data loss. So one will pick availability, one will pick consistency.
Right.
In a system like a relational database, it's either there or it's not. You can guarantee consistency and availability, so they don't have to worry about partitioning.
Okay.
In the new SQLs, they do have to worry about that because it's a distributed system. So therefore, they typically favor consistency. They don't have a choice over availability, but that typically sacrifices speed.
Okay.
So there's many factors when you're doing this migration. The first thing you really want to do is work out your business requirements. How big am I going to grow? That's key, because a lot of these databases look the same at small speed.
Okay.
If I'm talking 1,000 transactions a second and I've got gigabytes of data, a relational database can handle that, and almost every NoSQL will handle that.
Right.
But what happens if my gigabytes grow to terabytes, tens of terabytes, hundreds of terabytes, petabytes?
Right.
Where do I want to grow? And that really determines the NoSQL database I want to choose, or the infrastructure I'm going to choose. And they don't need to be mutually exclusive. SQL databases are not going to go away.
Okay.
We have many use cases where the SQL database, be it DB2, be it Oracle, whatever, is there for the system of audit and the system of compliance.
Okay.
But to get speed on top of it, you might want to divorce the transactions. You might want to say, I want my NoSQL database to be my intraday system of record,
Right.
and just trickle feed the transactions up into the system of record for those compliance reasons.
Okay.
Other use case, you might say everything's going to be NoSQL.
Absolutely fantastic. Now, since we spoke about the functionality and how we're going to actually look at as per our requirement when we're doing this migration, Tim, I would also like to understand something about the downtime. Now, what strategies can actually developers put forth or maybe use to ensure that there's minimal downtime during this entire migration when they're opting for it?
Okay. That's something that needs careful planning.
Okay.
There are multiple considerations, because not only minimizing downtime is obviously important, but you also absolutely want to guarantee correctness. So what I've seen happen very, very successfully is you have your old system, it's sitting there and running. Your new system comes along, and the aim is to replace the old system with the new system. But what you typically do, depending on how you ingest the data into your old system, is you'd run the systems in parallel. So let's say you're receiving your transactions or whatever you're working on via a message bus.
Right.
Have two things consume that message bus, the old system and the new system.
Okay.
Have them do the same work in parallel. Then compare the results. Given the same inputs, given the same data set, did I get exactly the same results? Run that for a period of time and then switch over. Because you're running them in parallel, you can effectively then switch one off, leaving the other one running without taking a moment's downtime.
Okay.
The big challenge comes in migrating the data. I want that initial set of data from my old system into my new system. How do I do that? If I'm doing these dual writes in parallel, I can simply take a snapshot of my old system and bring it into my new system.
Oh.
I'm taking those writes in parallel, but so I need to be a bit more careful.
Okay.
I've got historical data and new data coming in.
Right.
So you want to make sure when you're doing that, that the new data trumps the historical data. So if I've updated the Tim record, I want to make sure that if I had a previous Tim record and I'm trying to migrate in after I've updated the Tim record,
Okay.
that it doesn't overwrite it. So care needs to be taken. Have I only changed part of the Tim record, or have I changed it all? So there is a two-phase approach, and it depends on what your data looks like
Okay.
and how you can migrate it over.
Okay.
Some tools allow you to do this sort of continuous migration, but they're pretty heavy and you may not want them running in your system forever. So that dual write approach, once you've established that baseline of data, works the best. And I've seen very, very successful systems because it allows you to compare not only the inputs and the outputs, but performance. Is it fast enough to meet your business goals? Is it scalable enough going forward?
Okay.
So multiple strategies depending on your organization's risk and how long they can take an outage for. So some organizations can say, yes, I can stop for 3 hours. We'll migrate the final deltas over of that migration and then switch over. Others are 24/7. If you're going to know SQL, you're almost certain to want some form of 24/7. So you need to really plan that ahead of time.
Absolutely fantastic. Developers, I'm sure you're just making a note of what Tim has just shared with us. Tim, I'm sure everything comes with a certain set of challenges when we talk on functionality. And here we're talking about the migration. Help us understand, what are the common anti-patterns that can degrade the entire performance of NoSQL?
Great question. And it depends on the NoSQL. Obviously, there's a range of them out there. And it depends on what goals they're trying to meet. There's some common factors. So if I'm modeling my data in NoSQL the way I'm doing it in a relational database, it's probably going to be faster, but it's not going to be as fast as you could possibly get.
Okay.
So to give you an example, I did a workshop, and one of the things I looked at was credit card fraud.
Okay.
This real life use case that I've worked on in production. I wanted to take that and I ran it on a Postgres database.
Okay.
Worked reasonably well. Loading the records took about 400 milliseconds. I moved that information into a NoSQL database and ran the same sort of modeling on it, exactly the same way I would have done it relationally.
Right.
I did it in NoSQL. So I used a secondary index to try and find the records.
Okay.
Performance was better. It was about 10 times better. So I went from 400 milliseconds to 40 milliseconds, so 10 times better. But then I modeled it the way that was optimal for that NoSQL.
Okay.
And I got a further order of magnitude performance gain. So it went down to 4 milliseconds.
Okay.
So 100 times better than Postgres. But that was because I knew the data. I knew what my queries that I was trying to optimize for.
Right.
When you do NoSQL modeling, typically what you're trying to do is, I have high value business queries. These are things that there is a benefit to the business to do it faster. So credit card fraud, I've got my fraud window. I need to get the small time as possible to load those transactions.
Right.
If I'm doing digital identity management, I want to load that in as quick a time as possible so I can say, yes, this is Tim, without having to interrupt the flow of the transaction. That is the high value business. So you're going to model your data to match that. You probably have other reporting requirements where you say, I don't care if it's going to take me a long time to get a report, but I want to run a report against it.
Right.
You'd use other tools to do that, or wouldn't focus your modeling on that. You'd focus your modeling on the high value business problem that gives your business the best return.
Okay.
Other things to look out for. When you're doing this denormalization, I mentioned it earlier, but it's a key point. I want to stress it. If I'm denormalizing,
Right.
and many NoSQLs want you to denormalize, if your records become too big, they're too unwieldy, if I'm storing megabytes and megabytes of information, there's a cost to storage of doing that. Reading the same megabytes is expensive. So that becomes an anti-pattern. I want to do it to some level, but not too much of a level. And so there is a lot of art in the science as well. It's very difficult to say prescriptively, here's what you would look at. And so I've done this for a lot. I've been doing it for many years. So I can give you rules of thumb,
Okay.
but I typically want to look at someone's use case. And people say to me, what's the best way of doing it? My answer is almost always, it depends. What are you trying to do? What problem are you trying to solve? How do you go from here? So there's no way of beating experience. I give you guidelines to get started.
Right.
But typically, if you have problems, talk to an expert or do research and find out, what have I done wrong? And it's probably there's some way you're shooting yourself in the foot and you've managed to do it.
Interesting. Now let's talk about a little, while we are trying to handle the entire large-scale data reads and writes. Tim, so how can developers efficiently handle the large-scale data reads and writes in a NoSQL system?
Many of the NoSQL systems are set up for handling exactly that, large volumes reads and writes.
Okay.
For many of them, they have a preferred mode. So if I look at, for example, Cassandra. Cassandra is a great NoSQL database.
Okay.
It's designed for heavy writes. They simply go and write the data and they put it into a log structure. Now, the problem comes, that's very, very fast. The problem comes if I'm trying to read that data. I might have got 100 writes of the Tim record.
Right.
And they're all sitting there as different writes.
Okay.
Doing reads across them means I have to go and scan those backwards and find out what is the most recent write of the Tim record.
Okay.
So to optimize that process, they have a process called compaction, which sits there and merges the data and optimizes the processes for it.
Okay.
So it's really good for one, it's not good for the other. Other databases are really good at reads, but they're not so good at writes.
Okay.
Aerospike was designed to be good at both. So high reads, high writes, it doesn't matter. So know your technology. What is it good for? Sometimes if you're doing bulk writes, because the database will do sharding for you, it'll break that data up and spread it around the system. It's not normally as easy as a relational database. We can say, give me a file which contains my data, and I'll just go and copy that file over there.
Right.
They have to be broken up the right way the NoSQL database is doing it. So I know at Aerospike, we use the API to go and push the data in. You can do it other ways, but because of our very specific storage format, the fastest way is just have lots of threads, throw it at the source data, and do it very fast, and Aerospike will keep up. So it comes down again to your NoSQL database. Which one are you using?
Okay.
Some of them can take these compact SS tables. Many of them use these SS tables or RocksDB files, but make sure what your source system is actually fully compatible with your NoSQL database. Going through the API is the safest way.
Okay.
The same thing for reads. If I'm doing a lot of reads, many of them are designed to work in parallel. So I could say, let's say I've got 1,000 different records. I have different keys.
Right.
I know what those keys are. I want to do them in one hit. So there's concept of batch. I can go and say, here's my 1,000 keys. The NoSQL system will split them up and say, I've got 20 nodes. Those keys are on that node. Those keys are on that node. It will do them in parallel. Those nodes will do the work in parallel, feed the results back, and your application actually becomes the bottleneck. So it's consuming the data which is being streamed at you by massive servers. That gives you that the bottleneck, and that's a nice problem to have. It means that I can have more application clients doing things in parallel to try and get that parallelization across your database, and your database should keep up if you selected the right database.
Fantastic. Okay, so no discussion is complete without AI. I would like to understand from you that what are the realms that actually AI is being put into when we talk of this entire migration ecosystem?
Great question, and there's multiple facets. Because AI, as you know, is touching our lives in so many different ways. It's writing blogs, it's helping write code, it's doing a whole bunch of things. So there's the parts of helping design the migration strategy that AI can help with.
Okay.
There's the actual, I'm going to be using AI in future. I want to make sure my data is ready for AI.
Correct.
Let's approach that last one first, because one of the most common approaches that people are doing these days is retrieval augmented generation, or RAG. So we're all familiar with chatbots, where I give it a question and it gives me some answer. And the answer has context. It has meaning based on my question. In order to do that and work around the limitations of the LLMs, the large language models which are parsing and creating the data, I have to feed it information. I have to feed it context which says, here's how I would like you to answer the data. To do that, what I need to do is find the data and give it relevance.
Okay.
This is a way of using vectors. So a vector is a mathematical representation that says, I'm going to take this chunk of text or this image or this video or this part of a video, and I'm going to give it semantic meaning, and I'm going to put that vector associated with that. When I do RAG, I want to make sure that I find the most relevant vectors. So many databases are moving into a multi-model database where they have a vector component. Some extend that. Some have vector and graph and document and key value. So they're a combination of those. Some databases are pure vector databases.
Okay.
Typically, what I'm saying is pure vector databases are good, but there's a lot of traction in the multi-model ones because they say, I want to store my data, but I'm not doing just vectors. I'm not doing just, if I'm doing just a chatbot, then a vector database is great. But if I'm trying to augment my existing data with vectors so that I can do my normal business operations, but perhaps do other vector operations, then I need a multi-model database.
Right.
This, one of the other things that I'm finding is people are saying, is there a death of a vector database? Do we still need them? Because our context windows, how much information an LLM can process. I think a new one came out which has 2 million tokens. That's huge. I could give it the entire set of my data and let it work it out.
Right.
But even with those, the LLM is doing a lot of work. It is parsing 2 million, that's about 10 million characters. It's doing, each time you ask it a question, it's parsing the entire set of data.
Okay.
So it's doing an awful lot of work to try and work out what the right answer is. I'm not helping it. I'm not trying to give it a knowledge graph or a set of vectors which are pertinent. And I'm seeing a lot of commonality between a knowledge graph, which starts with a vector and then gives a graph, as opposed to just a single vector, which gives you just that one piece of information. But either way works where you feed that information there into the context, into the LLM to give the result.
Okay.
So AI has multiple facets on this migration. I think the world we live in now, we can't ignore that. When you're going and making a choice of a NoSQL database, you're going to be doing something with AI. What are you going to be doing? How do you need to use your data to do that? So, for example, shopping carts is a great example. Everyone's doing recommendation engines. That's a vector search. I've got a million products. Someone has shopped for a green sweater. Or maybe they want a green sweater with red stripes or something like that. So I want to show them similar products. Vector searches will help me do that.
Okay.
You can tell I'm a computer engineering because I just said that I said the words a green sweater with red stripes in the same sentence and didn't turn red at the thought of my fashion faux pas there.
Okay.
But yes, vectors are here to stay. AI is here to stay.
So I think when we talk of AI has become that magical wand which has been, doing that magic all around the industry and has been able to help us grow, innovate, and do our best in the terms of functionality where we are right now. And the innovation is like a consistent process which is in and out happening. I will now move on to the next segment that I have for you, which talks about the entire NoSQL and the compliance, Tim. So how does this entire NoSQL impact AICD compliance, and what workarounds exist for developers who are working on it or who are needing it?
Great question. Okay, so I'm going to draw the distinction between NoSQL and NewSQL.
Okay.
So NewSQL tends to be ACID compliant. They have taken a distributed database, and a lot of them are Postgres, but there's also MySQL compliant technologies out there. So TiDB, for example, uses MySQL, Cockroach uses Postgres. There's a good number of different databases out there. But the underlying data structure they use, they have to do compliance. So they have to be ACID level compliant.
Right.
Many of the NoSQLs don't, but there are some that do. So I know that distributed transactions in NoSQL, Mongo does them, Couchbase does them, Aerospike does.
Okay.
So those databases allow you to do the problems where you can't denormalize. Almost everything allows you to denormalize the data. So I've got one record which contains my business object and associated objects, and I can do atomic operations on those.
Okay.
That gives you the ability to sort of do ACID. If you can munge your data together and put them in the same record, then I can do atomic things on it.
Okay.
Other databases have shard level transactions. So if I look at Redis, it's a great database, but if I want to do multiple record transactions, they have to exist in the same shard. That means I've got to structure my data. So a shard is how we break up the data. If I'm trying to transfer money between accounts, for example, to do that, that would mean I need all accounts in the same shard, which means it all will all exist on the same node. No matter how big my cluster gets, it would all sit on the same node.
Okay.
So when you're designing something which needs ACID level compliance, I would either pick a database which has inbuilt ACID compliance,
Okay.
or I would look very carefully at my data and say, what do I need to do? Can it actually solve the problem based on whatever transactionality functions it's got? And it's not just now, it's going forward. It's a really easy trap to fall into, to say, I will pick a database that will meet my business requirements today.
Right.
But what about tomorrow? Will my scaling keep up? Will my business requirements change? If they change, do I have the technology flexibility to be able to adapt to those? So ACID compliance isn't the bugbear that it used to be. Many databases now offer it, even NoSQL, and they do it typically faster and at larger scale.
Okay.
So if I've got a relational database and I can do millions of records, I can do lots of transactions on that. But if I have billions or even trillions of records, can it handle that, doing lots of transactions concurrently on that? NoSQL should be able to.
Okay. So, Tim, we started our conversation with the entire setup of how this migration is done, what are the pitfalls, what are the patterns, the anti-patterns that exist, and the entire migration, the process, the segmentation that's there. When we talk of the future, the trends that would come for our developers, what are the things that you think you should talk about as emerging trends for NoSQL that developers should actually keep an eye on when maybe doing this migration, or they would like to do it in the future?
Yep. So obviously the big buzzword we spoke about is AI.
Yeah.
Now this AI is adapting. Very scary that AI itself is adapting, but there's different style of things. So agentic AI is becoming the norm. It's
Right.
becoming popular. It's the norm. I don't think people have realized business benefit out of it yet. It's sort of an unknown, but it's certainly a trend where we want to go in. Make the AI bots do meaningful work instead of just giving us answers. But then do you have a controlling agent which controls all the other bots? There's a lot of questions up there.
Okay.
So what I would do is pick something that is in the direction you want to handle with AI.
Okay.
We know it's going to be here. Everyone thinks that AI will give us an order of magnitude improvement in performance. I don't think we're seeing that in the industry yet. Maybe developers are seeing 10 to 20% improvement in their performance based on the use of Copilot and other similar technologies helping them code. We're also all aware of when you look at an article that you read, that one is, I can pick them and say, that one was clearly AI generated. It has a lot of words, but it says very little. So we need to be very aware of the limits of AI.
Okay.
So as I go forward, what I'm seeing is on the data space, we're going to need a lot more data. AI needs data to be able to give you the right results. There's different formats of the data that we're going to need to use. So the multi-model databases where graph is going to be very interesting, I think. We have knowledge graphs. I'm doing a search for something, but there's 5 articles related. I want to go and find those 5 things. If I'm doing an SQL to NoSQL migration, we're all familiar with joins. SQL joins are very, very powerful, but they're the bane of many people's existence. I've personally worked on projects where it's a 5-page bit of SQL joins, and without having written it and being very well commented, it's really, really difficult to follow. What they're typically doing in those joins is a graph.
Okay.
Imagine I have a bit of SQL and it's got a customer and I've joined with an account or a set of accounts and they have addresses. And what my query is something along the lines of, show me everyone who lives in this location whose account balances are greater than that.
Okay.
A bit of SQL can handle that, but it is a join between multiple different tables. But when you think about it, it's a graph traversal. I want to find any customers which have this on this object that's associated, which has this property, and I want to traverse that graph. So I see graphs becoming more important. I see AI using those graphs in conjunction with vectors. So you really want vector and graph, but performance and scalability is going to be key as well. So having that key value database or that fundamental database that can go and access those vast quantities in the right time to be able to feed these other systems is going to be very interesting. So looking forward, I think multi-model will become interesting. Most people are using SQL at the moment. I think I read a study recently which said about 50% of people are still using SQL databases and they're not planning on giving them up. And I don't blame them. They are the workhorse of their systems. But more and more, we're going to find a mixed model. SQL in conjunction with NoSQL, doing powerful things. And the use of these other technologies is scary because graph is new. I haven't written many graph queries in my developer, when I was writing engineering systems. I've written a lot of SQL systems. But as you start getting tools that are better suited for developers to do things, they're going to become more and more de rigueur. They're going to become more and more common. So I think looking forward, those multi-model databases are going to offer a lot of capabilities. And you're seeing this today. If you look at something like Postgres, it stores JSON blobs now. There's pgvec, which has the ability to do vectors on top. So they're trying to adapt these relational systems to these new trends, but whether they're powerful enough and scalable enough to be able to handle what we're trying to do here is another question.
Fantastic. Now, as we come to the end of our show and discussion here on with Tim, I would like to shift the dimension a little different here. It's very obvious that you love data, right? But I would like to know, if you weren't working in data infrastructure, what field do you think you'd be in, given a choice right now?
It's a great question. There's a lot of things I would love to explore. I really like making pretty things. Now, I'm an engineer. I have almost no artistic ability, but the ability to leverage AI. I did a lot of ray tracing and designing scenes like that, because I think having computers generate things is very cool. I'd love to get into some form of generative AI and the ability to help and just make people's lives happier. Everything I do in software is designed to make people's lives better in some way, or write software systems which makes people's lives easier. But does it make people happier? I really enjoy doing something like that. I'd love to be able to spend more time. I'm a gamer. I like writing games. I'd really like to do that because they're cool, they're fun, and they're chill. They help people relax. And, I find that personally, I'd love to spend more time exploring that other side, writing user interfaces. It's not something that I'm particularly good at, but it's something that I really like seeing and doing, and I'd love to learn more about. There's so much out there in the world that I'm very focused. I've been a nerd my entire life. I think I wrote my first computer game when I was 11.
Oh.
It was like I was hacking 6502 assembler code, just aging myself dramatically here.
Wow.
So I've really been a nerd my entire life, and it's what I'm good at, it's what I enjoy, but I'd really like to get outside and explore these fringe areas a lot better.
I absolutely love that, Tim. Thank you so much. I think this conversation has been really, really insightful. Thank you so much for joining us for this conversation in the podcast today.
Well, it's been a real pleasure, and thank you for taking the time, and really appreciate the opportunity.
Thank you. Folks, we should be, talking about the entire migration, SQL, new SQL that Tim has just mentioned about. Catch this episode very soon, and stay tuned to TechGeek for more tech dives and conversations. Thank you.